In March 2024, a developer named Andres Freund noticed something boring. His server was responding exactly half a second slower than usual. Most people ignore a 500 millisecond delay. It's a minor lag you blame on your router before closing the laptop and moving on. Andres didn't. He sat there and started digging into the source of the slowdown. That investigation uncovered a vulnerability that would have granted an unknown attacker access to the systems running the modern world, from banks and hospitals to government infrastructure. The world's most popular operating system is one most people have never consciously interacted with. It's called Linux. Look inside a data center and you'll find Linux. It runs 3 billion Android devices, it handles the majority of internet traffic, and every single one of the top 500 supercomputers on the planet. The stakes are physical. This software is the administrative backbone of the Pentagon and the guidance systems for U.S. nuclear submarines, like the USS Kentucky. The standard for controlling these systems remotely is a protocol called SSH. It creates the encrypted connection that allows administrators to manage servers from anywhere in the world. Because it is so critical, the main open-source version of SSH is one of the most intensely audited pieces of code in existence. To find a flaw in the protocol itself, an attacker would have to outsmart thousands of the world's top security researchers. To bypass a system this secure, the attacker had to look elsewhere. They targeted a dependency, a tiny, unnoticed piece of infrastructure running underneath the floorboards. That dependency is a compression tool called XZ. It's used by almost every major Linux system to ship data between machines. It is universal, essential digital plumbing. XZ exists because of an idea born in the 1980s at MIT. A researcher named Richard Stallman argued that software should be public, something built and improved together rather than locked away by a manufacturer. In 1991, a student named Linus Torvalds adopted that open license for a hobby project called Linux. He released the code to the world, inviting anyone to help build it. This model relies on Linus's law, the belief that if anyone can see the code, everyone can fix it. Security flaws are supposed to be caught faster because of the sheer number of people watching. But that law assumes the crowd is actually looking at the boring parts. Linux isn't one giant project. It's a collection of thousands of small tools, many of them maintained by people working alone. For 15 years, XZ was maintained by one volunteer in Finland named Lasse Collin. He did it for free on weekends. By 2022, he was overwhelmed, publicly posting about long-term mental health issues and his inability to keep up with the work. Then a developer named Jia Tan arrived. It was a patient social engineering operation. Fake accounts manufactured community pressure to stress Lasse, while Jia Tan stepped in as a highly skilled contributor to take the load off. Over 2 years, Jia gained enough trust to hand over malicious code. He hid it inside binary test files, blobs of data used to check compression performance. These files aren't readable by humans. They're assumed to be garbage. When triggered by a specific encrypted key, that code would silently modify how the server handled logins. It would grant the attacker administrative access while bypassing the entire security layer of SSH. Jia Tan spent 2.5 years weaponizing a volunteer's burnout. He came within weeks of placing a backdoor in the majority of the world's servers. Back in the present day, Andres Freund followed the trail of that half-second delay directly to the binary test files. He realized they were never actually used for testing, and he quickly published his findings to a security mailing list. The response was immediate. Major Linux distributions rolled back their updates. The compromised version of XZ was yanked from development pipelines before it could reach the stable versions used by most servers. Jia Tan disappeared. Traces of activity pointed to multiple time zones, leading analysts to suspect state-sponsored groups in Russia or China. But the attacker remains a ghost. This attack was stopped by luck. It wasn't an automated scan or an AI security system that caught the backdoor. It was one developer who got annoyed by a microscopic delay on a Tuesday afternoon. Security researchers are now asking the obvious question. If Jia Tan almost succeeded, how many other patient actors are currently working inside other critical projects? This case exposed a structural weakness in the internet. Trillion-dollar corporations are building their products on top of free infrastructure maintained by exhausted, unpaid volunteers. Linus's law only works if people are actually watching. That's the experiment. Not just in software, in every system we've built on the assumption that someone else is handling it. The next experiment is already running, and this time nobody might be there to notice the half second.